right, so we are on page 188 in the textbook here. How elements form compounds. What do you think a compound is? Like, what does compound mean? It's literally two elements put together. Actually, I think, Nathan, it's two or more if I'm not mistaken. Oh, no, maybe it's just two. You're right. Okay, so the model you've just learned of with atoms losing or gaining electrons to become stable explains how some compounds are formed. For example, both sodium and chlorine are highly reactive. What does that mean?
They blow off.
They're explosive. They react very easily, right? Atoms of these elements combine by transferring electrons from one to another, as shown in figure 1. Sodium chloride is a relatively harmless compound because the sodium and chlorines have formed stable ions. They're happy. When they're in their sodium format, not so happy. They got that extra electron they want to get rid of. Chlorine wants another one to be happy. Once they get together, they're happy. The compound formed is called an ionic compound because it is made up of positive and negative ions that have resulted from the transfer of electrons from a metal to a nonmetal. The positive and negative ions are attracted to each other because they have opposite charges. Figure 2 shows some common ionic compounds. Let's just have a quick look there. Where's figure 1? There's sodium. Figure 2, oh here, limestone, sodium chloride. Where do we see regular sodium chloride? Like, where could you find that in your house? In your salt shaker. Every time you put salt on your fries, you're putting metal on your fries. Everyone needs some sodium in their body. You have to have a certain amount of sodium. Too much is bad, right? As in most things, moderation. Consider a slightly more complicated example. Calcium and fluorine react to form calcium fluoride, an ionic compound. Each calcium atom has 2 electrons in its outer orbit that it tends to lose to become more stable, or wants to lose. Each fluorine atom has 7 electrons in its outer orbit and needs to gain only 1. How can this mismatch of electrons be solved? The solution is that one calcium atom requires 2 fluorine atoms to form the compound calcium fluoride. So let's just, I'm just going to draw those out for you, okay? Again, if you want to just sit back and watch, if you want to make some notes, you can. If you want to write everything down, you can. You do what works best for you. You go away. Yeah, absolutely. You can watch it there. So remember, ions are atoms that have taken in or given off electrons. An ionic compound is made up of positive and negative ions. There's a transfer of electrons from positive ions to negative ones. Let's do an example here. And the classic one is sodium chloride, NaCl. Okay? This is the most simple, basic ionic compound there is, because everyone knows what sodium chloride is. It's plain old table salt, and it's so simple. What is the Lewis dot diagram for Na? How many electrons does Na have in its outer shell? I think it's got 1, am I right? Isn't sodium like number...
Yes, it does.
It's number 11, right? It's in the first column. It's right there. It's in the first column. It's got 1 in its outer shell, so it's got Na like that. I'm going to color that in. You might know why I'm coloring it in a bit. Cl is way over here on the right. It's a nonmetal. How many does it have in its outer shell? Like 7. In fact, 7. These two are the perfect match. How come?
Because the sodium can fit into there.
Yeah, like sodium's got 1 to give away, right? Chlorine would really like to have 1. These guys, perfect jigsaw piece puzzle. Perfect match. Okay? So, sodium comes along and says, hey, chlorine, I got an extra electron for you. This electron right here goes over there. Now what happens? Na is perfectly happy. It's given away an electron, so it's become positive or negative. Given away an electron, given away a negative, Mike, so it's going to be positive. Correct, you are. Chlorine now has taken in an electron, so now chlorine is negative. And now you've got a happy, stable sodium ion. You've got a happy, stable chlorine ion, and they just happen to be oppositely charged, 1 positive and 1 negative. And so they are attracted to each other. So they sort of snuggle up a little bit, like so. and you get what is known as an ionic compound. If you were to take a 1 grain of salt, could you like take a really sharp knife and split it and turn it into sodium and chlorine? Sure. No, they like to be together. You're not going to go in and break them up. The only way to break them up? Yeah, put them in water. Well, I suppose there's water in your mouth, right? Right? You can break them up that way. Okay? This is known as an ionic compound. Now this is a 1-to-1, right? It's 1-to-1. Its formula then is NaCl. Now the other one that they're talking about there in the book is calcium and fluorine. Let's do this one. Calcium and fluorine. I'm going to do the same thing here. Okay, look at your periodic table. How many does calcium have in its outer shell? I think it's in column 2, is it not?
Yeah.
Column 2? It's in 2. Okay, so calcium has 2. Fluorine is period 7, I believe. Am I right? Okay, so I've got 1, 2, 3, 4, 5, 6, 7. Now, this is not such a perfect situation because calcium, if it gives 1 away, still has 1 more, right? Fortunately, when you sort of mix calcium and fluorine, are you mixing 1 atom and 1 atom together? No, like they're like teeny tiny, right? You've got millions of calcium and millions of fluorine. Unlimited supply, really. Okay, so what really needs to happen is you need 1, 2, 3, 4, 5, 6, 7. You need 2 fluorines for that 1 calcium. Okay, so we've got 2 fluorines here. So calcium can do what? One of these electrons can go in here. One of these electrons can go down here. Everybody's happy. Calcium has a charge of? See? How many electrons did calcium give away? So it has a charge of 2 positive. Each one of these fluorines has a charge of each -1. And so the calcium sort of does this. It sort of snuggles in there, and it's attracted to both at the same time. What would be, then I'm doing a little bit of sort of forward thinking here, what would be the formula? Like if you had to write out the formula for calcium fluoride, you would have CaF2, right? 1 Ca and 2 Fs, CaF2. You don't need to know that just yet, that's tomorrow. That's really how it works. Like, it's not rocket science, it's chemistry. We'll get to that one. Good question. I think it's ionic, is it not? Hydrogen. Yeah. Hydrogen's over on the left side. Okay. So, chemical formulas here. Page 189. Maybe I am wrong. Maybe it is today. A chemical formula is a combination of symbols that represents a particular compound. As you've seen, ionic compounds can be represented by such formulas. The formula MgCl2, or magnesium chloride, describes a compound in which the combining ratio of magnesium ions to chloride ions is 1 magnesium ion to 2 chloride ions. Man, they sure make it sound hard, don't they? There's 1 magnesium, there's 2 chlorines. That's all we got to say. Similarly, the formula AlF3 just means 1 Al. How many Fs? 3. It's really not that hard. They make it sound hard. Ionic compounds dissolve in water to form solutions that conduct electricity because they are made up of charged ions. If you put the salt in the water, I have to go back one screen. If you put the salt in the water, the Na and the chlorine separate. And because they have charges, electricity will travel through water. You all know that if you're out in a boat in a lightning storm, you should maybe not be in a boat in a lightning storm, right? The electricity will travel through the water. You should not sit in the bathtub and try to make toast. Bad idea, right? The electricity will travel through the water. What makes it even worse is when there's what in the water? Salt. Salt water is even worse to be in when there's lightning or electrical. Okay? Yeah. Blah, 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 blah. Okay, we don't need any more. That's enough. Alright, so I need to do just numbers 1, 2, 3, and 4 on that page. On that page there, 189. 1, 2, 3, and 4. Stop there and then we'll correct. Question number 1, just write down example sodium and chlorine. Okay? And then you would say something like, sodium has how many valence electrons? No, it's only got 1. Sodium. Sodium wants to give away an electron. Chlorine wants to take it in. Say, sodium wants to give away, chlorine wants to take one. That's what you write down. Once sodium has given away its electron, what kind of charge does sodium have? Positive. So then you write something like, sodium is now positively charged, or sodium has a positive charge. Chlorine is taking in that extra electron. What is its charge now? Negative. So you write something like, chlorine is now negatively charged. Sodium is positively charged. Chlorine is negatively charged. Now that they're opposites, they fit together. They attract each other. Positive and negative attract each other. That's how they form compounds. The sodium ion is attracted to the chlorine ion. That's all you got to say. You're good. That's basically A and B together. No. Now I think you can do number 2. Can you not? Beryllium and fluorine react to form an ionic compound. Which one is the metal and which one is the non-metal? So just tell me which one is which. Draw Bohr diagrams of beryllium and fluorine. How many electrons must each element gain or lose to form stable ions? Draw sketches to show how the compound forms. Indicate the ionic charges. What is the overall charge? And what is the chemical formula? I know you can do this. I'm going to give you 2 minutes, no, 4 minutes, and then I'm going to do it. Go ahead, Chance. Give it a try. Let's have a look at this one here. So we're talking about beryllium and fluorine. Which one is the metal and which is the non-metal?
Beryllium.
Yes, beryllium. Be?
Yes.
Beryllium is the metal. It's over on the left. Right? Fluorine is the non. It's over on the right. Draw Bohr diagrams of beryllium and fluorine. Chance, remind me again. Beryllium is number 4, right? Okay, so it's got 1, 2, 3, 4. Fluorine, I think, it's number 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's part B. Part C, how many electrons must each element gain or lose to form stable ions? Beryllium wants to give away 2. Fluorine wants to take in 1. Am I right? Draw sketches to show how this compound forms by transfer of electrons. So what they want you to do is they want you to show how this is going to work. So this, let me just do this. Right? These ones here should go, I got to separate them. Okay, you guys, come on, pay attention. We'll do a black one and a red one, right? Okay, the black one wants to go in here. The red one wants to go somewhere else, right? So what am I going to need? I need another one. You know what? Let's not use Bohr diagrams. Let's go like this. Let's write BE.
So your question is...
Well, no, I'm just saying I understand it's hard to draw. I get that, right? It's easier to sort of explain verbally. It's hard to draw. I get that. Fluorine's got 1, 2, 3, 4, 5, 6, 7. Right? This one here goes in there. And what do I need? I need another fluorine for this one to go in there. That's what they want. A sketch kind of like that. That's what they want for part D. Can you draw that for part D? Like, I think you guys get all this, right? Like, I don't think it's I think you get it. You just don't want to write it because it's boring. I get that. But I need to know that you get it, because if you don't get it, then I got to make sure you get it.
So you should scratch
If you can show me that you get it, I can stop yakking about it.
You guys just scratch it.
I can't do that. I need to know that you got it. Can't.
So that's like.
Can't. Indicate the ionic charges on the ions. Be is going to be, because I give away 2, is going to be a
2.
2 what?
Positive.
2 positive. Fluorine, because I take in 1, Mike, is going to be a what?
1 negative.
1 negative. See, I know that you guys get this. What is the overall charge on the compound? The total charge.
Neutral.
Exactly, neutral. Big fat 0. And then what's the last question? What's the formula? What is the chemical formula?
EF2.
Excellent.
Yeah.
BeF2. Explain why it's BeF2 called.
Because there's 1 beryllium and
Exactly. There's 1 beryllium and there's 2 fluorines, and so that's the way it works.
what is that?
BeF2. That's G, right? That's G. Okay. I want you to do number 3 for tomorrow. I'm assigning homework. Ooh. All I want is number 3 for homework. Do the same thing that I just did for aluminum and fluorine. Do the same thing that I just did for fluorine. Okay? I'm even going to make it even easier for you. All I need is this. That's the only part I want is the Lewis diagram, the charges, and the formula. That's all I need. You got 3 minutes. You can do it now. You got 3 minutes. You could do it now. Aluminum and fluorine. You could just hammer it done.